Welcome to the YouTube channel Math Skill. Today we are going to discuss about the chapter Quadratic Equations. Numerical is find two consecutive odd positive integers, sum of whose squares is 290. This is part of CBSE as well as NCERT for 10th standard mathematics. This is a solved problem. I am your trainer Venkatesh K. Let's note down the problem. Noted down the problem. Now the ask is we will have to build a quadratic equation and solve to find out two consecutive odd positive integers such that the sum of whose squares is 290. Now before assuming how the consecutive odd positive integers would be, let's try to understand some basics about the number line. Let us assume number 5 on number line. I've taken number 5 on a number line. The preceding odd number for number 5, that is the next odd number for number 5 would be number 7. Similarly, the preceding odd number or the previous odd number for number 5 would be number 3. In similar lines, if x is assumed as one of the number which is odd on number line, then the next or preceding number would be x plus 2. Similarly, the preceding number would be x minus 2. Because we have to assume two consecutive odd positive integers, that is, we will have to take a pair of two numbers. So that two numbers would be assumed as x minus 2 and also x, or x and x plus 2. These two would be one of the pairs. Therefore, let's assume the required numbers as x and x plus 2. Now coming to second part of the condition, wherein he says the sum of whose squares is 290. So since we have assumed the numbers as x and x plus 2, we will have to square them and then add them so that we will be getting 290. This is the second condition what is given. Now x square plus x plus 2 whole square is equal to 290 is what we are getting. Now the second term is looking like a plus b whole square, which is equal to a square plus b square plus 2ab term. So now we observe that wherever there is a in the equation, in the formula, there is x in the equation, and wherever there is b in the formula, there is number 2. Therefore, let's apply the formula with a is equal to x and b is equal to 2. Upon application of the formula, the first term would remain as it is, x square would remain as it is, and RHS 290 would remain as it is, whereas for the term x plus 2 whole square, we have applied formula which is a square, that is x square, plus b square, which is 2 square, plus 2 into a into b, that is 2 into x into 2. Upon simplification, x square and x square is like term, that is they both will get added to become 2x square. 290 would remain as it is in RHS, whereas 2 square is becoming 4, 2 into x into 2 is becoming 4x. Let's take 290 from RHS towards LHS, that is upon transpose plus 290 would become minus 290. Upon transpose, this has become minus 290 term. Now let's rearrange and simplify. 2x square and 4x, because they don't have any like terms, so they would continue to remain as it is, whereas plus 4 and minus 290 would get simplified and we would be getting minus 286. Now we see that all the terms are having a factor of 2, that is all the coefficients and the constants are even numbers. Let's take 2 common. Upon taking 2 common, now we see that 2 is taken out from 2x square, so therefore x square is left. From 4x, 2x is left. From minus 286, we would be left with minus 143. Upon transposing of 2 from LHS, which is getting multiplied here towards RHS, so it would get divided by 2, that is 0 divided by 2 is what we are getting on RHS. 0 divided by any number would be 0. Therefore, the equation would be x square plus 2x minus 143 is equal to 0. This equation cannot be simplified further as we contain unlike terms. Therefore, this has to be now simplified to find out the value of x. This equation looks like the standard form, that is ax square plus bx plus c. That is, it contains the first term as a x square term, second term as a x term, and third term is a constant term. Therefore, upon comparison of coefficients and the constant, we can conclude that a is equal to 1, b is equal to 2, and c is equal to minus 143. That is what is noted down. Now let's apply the quadratic formula to find out the value of x. We know that the quadratic formula is equal to x is equal to minus b plus or minus square root of b square minus 4ac whole divided by 2a. That is, wherever there is b in the equation, we will have to substitute by 2. Wherever there is a, substitute by 1, and wherever there is c, substitute by minus 143. Now let us see how to simplify this. So in this equation, as I was saying earlier, let's substitute the values with a, b and c as noted down. So we would get this equation as within square root, I'm getting 2 square minus 4 into a is 1 multiplied by minus 143 whole divided by 2 into 1. Now in order to simplify, the outside terms minus b and also 2 into a, that is 2 into 1 is 2. So these would remain. Now we will have to, before simplifying with these terms, we will have to simplify the square root term, that is 4 plus, so minus into minus is plus, and 4 ones are followed by 143 is what we are getting. So in order to simplify, 4 into 143 is 572. Let's take this value and substitute in the equation, that is within square root 4 plus 4 multiplied by 143 is substituted by 572. 572 plus 4 within square root is becoming 576. Now let's find out square root of 576, which is actually equal to 24 square. So 24 square is equal to 576. To find the value of x, let's substitute here, which is x is equal to minus 2 plus or minus square root of 24 square whole divided by 2. So square and root will both get cancelled. So we would be left with minus 2 plus or minus 24 divided by 2. Therefore, x is equal to minus 2 plus 24 whole divided by 2, or minus 2 minus 24 whole divided by 2. Or 24 minus 2 is 22. Here minus 2 minus 24 is minus 26 divided by 2. 22 divided by 2 is x is equal to 11, and similarly x is equal to minus 13 is what we are getting. Because we want to get, we want to find out the odd positive integer, so negative values of x cannot be considered. Therefore, what we will do is, since we want odd positive integer, we would not be considering x is equal to minus 13. Therefore, the required number or one of the number is x is equal to 11 is one of the odd positive integer which is required. Now, in order to find the other number, it is x plus 2. Consecutive odd positive integer is x plus 2, that is 11 plus 2, or other number is 13. Therefore, the required numbers are 11 and 13, which are odd as well as consecutive and positive integers. Thank you.